Welcome to part 2 of Ohm's law. By Ohm's law, if a current I flows through a conductor, it produces a voltage V across it, and V is proportional to I. Therefore, V is equal to a proportionality constant R into I, where R refers to the resistance of the conductor. The circuit symbol used to denote resistance is this. So by Ohm's law, current I flowing through resistor produces a voltage across it with this polarity V. Let us suppose we have a resistor like this of value R1. If a current I1 flows through it, then the voltage set up across R1 will have this polarity, and V will be equal to I1 into R1 by Ohm's law. Let us suppose that we have a resistor R2, and if a current, let us say I2, flows through it, then the voltage set up across R2 will have this polarity. And let the voltage be V2. So V2 is given as I2 into R2. Let us suppose that we have two resistances, R1 and R2, connected in series, and let us pass the current I through the series connected resistors R1 and R2. Then this I will set up a voltage across R1 and R2. The voltage set up across R1 will have this polarity, where the voltage V1 is given as I into R1. Similarly, the voltage set up across R2 will have this polarity, and the voltage is given as V2 is equal to I into R2. And here we say the voltage across R1 is rising in this direction. Similarly, the voltage across R2 also is rising in this direction. So the total voltage rise across both R1 and R2 will be this. So the net voltage rise V can be given as the sum of the voltage rises V1 and V2. So V is given as V1 plus V2. So this current I is setting up a total voltage of V across R1 and R2 put together.